This is a video for AQA Discrete Mathematics, Critical Path Analysis, section 1.3, where we're looking at critical activities and critical paths. Well, to discuss critical activities, we first need to define what we mean by the float time. This is the slack that might be available in a particular activity. The float time then is the spare time associated with an activity. So if, for example, we have an activity with a early start time of 4 and a duration of 7, then it could possibly be completed by time 11. But if the latest time of completion was 13, it then has some slack or float associated with it. So just putting that down in terms of some activity. If the boxes underneath the activity read like this: 4, 7 and 13, then the early time is 4, the duration is 7, so possibly could be finished by time 11 if nothing goes wrong, but it has to be finished by 13, so we've got 2 units of time as float. Now if, as is the case with some of the activities, there is a 0 float time, then that is a critical activity. This just means that, for example, we might have another activity with just looking at the boxes underneath again, where we've got a earliest start time of 6, a duration of 9, and the latest finish of 3, I beg your pardon, a latest finish time of 9, then you can see there we've got no float, because the earliest it can be finished is time 9, and it's got to be finished by time 9, so there's no way that any float is then. So float, and 0 float in particular, given these critical activities, tells us about the activities which must be completed on time. All the other activities are what are called non-critical. So they can have a little bit of delay without causing any effect on the end of the project, but these critical ones can't. Any delay in a critical activity means that the project is bound to be overrunning. So here we've got 2 activities G. We can see for this one, for G, the float here is going to be equal to 15 minus 1 minus 13, so that gives us a total of 1. Whereas for H, the float is equal to 16 minus 3 minus 13, which is 0. So this is a critical activity. So we can say the following, that if the late finish time minus the duration is equal to the early start time, then this is critical. So for H, 16 minus 3 is 13, and that's the same as the early start time. And then if it's non-critical, we can say that the float is equal to the late finish time minus the duration minus the early start time. So for example, in G we had 15 minus 1 minus 13, giving us a float of 1. So here's a network activity diagram that we looked at in an earlier video with all the early and late times on there. So we want to look for the activities which are critical. In other words, they've got 0 float time. And if we look for those, we'll see that, for example, well, certainly A is a critical activity, so is D, and F, because we've always got these numbers. 13 minus 1 is 12, which is equal to the early start time, for example. If we look at G, that's non-critical. 15 minus 1 is 14. But H is critical, J is a critical activity, and obviously that comes to the end. If we look back at B, E and C, none of those are critical activities. They all have some float time associated with them. For example, E has a float time of 1. 12 minus 2 is 10, and minus 9 giving you 1. Once we've got the critical activities, then we can produce what's called the critical path, and that is just a path going from start to end which follows these critical activities. So our critical path would be A, D, F, H, J. Now, although we can use the highlighter, probably not an exam, the best idea to use a highlighter. Do it by scribbling over, just lightly scribbling over the lines, the arcs, rather than a highlighter, because the highlighter won't show up for the examiners so easily. But then what you should do is list the critical path, which is A, D, F, H, J. Now, note that there may be more than one critical path. So let's look at a second example. Here again, one that we did in an earlier video. The critical activities are A, certainly critical. If we go along the top, F is not, neither is C. Comes down to D. D is a critical activity. B and E aren't. Then coming down, we see that G is, H is, J, I, and K. So this time our critical path is quite complex. So there's maybe more than one path going from start to finish. So you can see here it goes A, D, G, I, K, and also branches down to H, J, and K, and from G to J. So you need to list all of that, and so we would say that the critical paths are A, D, G, I, K. Then I would tend to list them separately, I think. A, D, H, J, K, and A, D, G, J, K. If you wish, you could just do it as a branching diagram, but probably better to list all three different paths. You could do it as A, D, G, I, K, and then just show that it also branches from D to H to J to K. That should say K at the end there, and from A, D, G, J to K. So it looks a little bit untidy like that, so I think the best way is to list all of the paths separately. Well, that's the end of this video on critical path analysis. Indeed, it's the end of the section on critical path analysis.